All right, hey everybody, today we are starting by talking about volume of prisms and cylinders. Volume is the number of cubic units that can fit into a figure. So like if I look at this cube right here, it is a 3 by 3 cube, and there are 27 single 1 unit by 1 unit cubes that fit in. That is what volume is how many cubes fit into a space. Looking down here, we're talking about Cavaliere's principle. Basically what happens is if your figures have the same height and the bases are the same, okay, so that way every cross section has the same area, then they have the same volume. We'll look at that a little bit more in a little bit, but basically this is called an oblique prism because it's tilted. This is a right prism because it's straight up and down. So that's this information over here. We have a right prism and an oblique prism. So I did not put that on your notes, so if you want to make a little note of that, you can. So my volume formula for prisms and cylinders is V equals capital BH. It's really important that you write a capital B because capital B means area of the base. A lowercase b means length of the base. So it is really important that you make sure that you have the difference between those two. Okay, now the formula V equals capital BH is going to be on your reference sheet. It is the only one of the 1, 2, 3, 4 on this page that you see. Okay, your rectangular prism you can rewrite as length times width times height because that length times width, the base is a rectangle. Okay, formula for volume of a rectangle is length times width. Okay, so that's why this formula comes in, but this formula is the same as this formula. The same thing here when our volume is side cubed for a cube. Okay, here my base is a square, so it's S times S, then I multiply it by the height, which is S, so it's S times S times S. All right, so these are just little shortcuts that you can take. As long as you know this one, you can figure out these. You don't have to learn them separately. The same thing here with volume is pi r squared times height. Because we've got two bases, our formula is still area of the base times height. It's just that now my bases are circle and area of a circle is pi r squared. So it's area of the base, which is my pi r squared, times height. And again, this is a right cylinder and an oblique cylinder because it's leaning. Same thing here, right prism and an oblique prism. Notice that it's the same formula for both of those. All right. So we are going to start here by finding the volume of my prisms. So what I'm going to start with is I am going to keep my formula volume is area of the base times height. Okay, just so that you kind of see how this one works. I am going to shade the base. I highly recommend that you guys do this when you're working your formulas, so that way you always come back to knowing exactly what your base is. All right, so the area of my base, because it's going to be a rectangle, it's going to be, I can either say length times width or base times height. I still like using base times height. Okay, but the base and the height of my rectangle are 10 and 12. So the area of my base is 120 centimeters squared. Okay, so now I know that the area of my base is 120. Okay, now the height of my prism is the distance between the bases. So it's the number that you didn't use to find capital B. So the height of my prism here is 8. Okay, then I'm going to take 120 and I'm going to multiply it by 8 and I'm going to get 960 centimeters cubed is how we write our units for volume. Okay, now realize that in this particular figure you could have picked any pair of sides. I chose top and bottom to be my bases, but you could choose left, right, or front, back because they're all rectangles. Okay, all right, for B here we have a cube with length edge 10. I'm going to go ahead and just use that little shortcut formula with volume is side cubed. Because it is actually a whole lot easier if you do remember that one. Okay, so volume is 10 cubed and 10 cubed is 1,000. So here I have 1,000 centimeters cubed. Okay, so these are my answers for A and B, and we're going to get to C here on the next slide. All right, so C is a little more challenging. I have a right regular pentagonal prism with base edge with a length of 5 and height was 7 meters. Okay, first things first, my base is the pentagon because it's not a rectangle. Okay, so my bases are the two pentagons. So I'm going to shade my base. You can shade one or you can shade both. It doesn't matter. Sometimes it's easier just to kind of shade one. But just remember that this is the other base, okay? So my base edge has a length of 5. The height is 7, so this is my 7. Now notice your picture is over kind of in that left-hand column, and then this one's actually in the box. Okay, so the first thing that we have to do here is to find the area of the base. Well, my base is a regular pentagon, okay, so that means that I need to use my 1/2 AP. So I'm going to start by finding all the pieces that I need. I know that my perimeter is the number of sides times the side length. So for my pentagon, remember, I'm not looking at any of the rest of the figure right now. I am only looking at the pentagon. I have 5 sides and they have a length of 5. So my perimeter is 25. Now, to find the apothem, because again, we need 1/2 AP, this is where we're bringing back everything we did in chapter 10. Okay, I get this angle measure here by doing 360 divided by 5 and then divide that by 2. So I'm going to get 36 degrees right here. Okay, this is the apothem that I'm looking for. I know my side lengths are 5, which means that this is divided equally into sections that are 2.5. Okay, so this is my opposite side, my adjacent side. So I'm going to be using tangent. So I'm going to say that the tangent of 36 is equal to my opposite, which is 2.5, over my adjacent, which is my apothem. Okay, variables in the denominator, so we're going to be dividing by our trig function. So it's 2.5 divided by the tangent of 36. And when you put that in your calculator, you're going to get 3.44095. Remember, do not take that out of your calculator. Okay, now that I have my apothem, which is this 3.44095, I can find the area of my base. So the area of my base is going to be my 1/2 AP formula. So it's going to be 1/2 that apothem, which that number you should still have not taken out of your calculator. That 3.44095 should still be in your calculator. Ignore that, kind of looks like another decimal. It's not. Okay, and then times the perimeter, which is 25. When I put this in my calculator, I get 43.0119. And again, leave that in your calculator. Then we're going to find our volume, which is area of the base times the height of the prism. So when I look here, I'm going to have my area of the base is 43.0119. And then the height of the prism is the distance between the two pentagons. So it is 7. So in your calculator, all you have to do is times 7, because that number should still be there. And now we can round to the nearest tenth, which is what our original directions said. And our volume is 301.1 meters cubed. Okay. So let's go ahead and take a look at cylinders. Okay, we want to give our answer in terms of pi and to the nearest tenths. So my formula is volume, again, is area of the base times height. But my base is always a circle in a cylinder, so the area of a circle is pi r squared. So we're going to do pi r squared times height. Okay? So when I plug it in here, my cylinder is an oblique cylinder, but that doesn't matter. My radius is 8, so I'm going to square 8. I'm going to multiply that by my height, which is 12, and then multiply that by pi. So 8 squared is 64, and then we do 64 times 12 to get us 768 pi, and that is going to be centimeters cubed. And then we put that in our calculator. We do 78 times pi to get to the nearest tenth, which is going to be 2,412.7 centimeters cubed. So this is my answer in terms of pi and to the nearest tenth. Okay, with part B, we want a cylinder with a base area of 36 pi. So when we go back to that area of the base times height, they gave us that this is going to be 36 pi. Okay, but now it says a height equal to twice the radius. Okay, well, we don't know what the radius is. So that means I know that the area of the base is 36 pi. So my area formula, remember, is pi r squared. So I know that 36 pi is going to equal pi r squared. I can divide both sides by pi, and I'm going to have 36 equals r squared. Square root both sides, I get that 6 is my length for my radius. Now, my height, it says it's equal to twice the radius, so it's going to be 2 times r. So my height is going to be 12, because it'll be 2 times 6. So now we can do our volume formula is area of the base times height. Because again, I'm going to use this one because they already gave me area of the base. So it's going to be 36 pi times the height, which is 12. So I'm going to do 36 times 12, and I'm going to get 432. Then that'll be times pi, and we're in inches, so it is inches cubed. And then when I multiply that out, I'm going to get 1,357.2, and again, that is inches cubed. So there is my answer in terms of pi and to the nearest tenth. All right. So we are going to go ahead on to the next problem. Let's look at example 3. And we are going to find the volume of the composite figure. What is happening in this figure is we have a cylinder with a rectangular prism actually pulled out of it. It's hard to tell, but this piece here on the inside is actually hollow. All right, so what we're going to do is we're going to take the volume of the cylinder, and I can't spell cylinder, okay, and from that we're going to subtract the volume of the prism. Okay, so my volume of the cylinder is pi r squared times h, and we're going to subtract from that my volume of the prism, which is area of the base times height. So let's start over here. My radius, notice that they give you the radius of this square base, okay? So that is the radius of the cylinder, so it's 3, so it's 3 squared. The height of the cylinder is 5, and we're going to multiply that by pi. So this is going to be 9 times 5, and it's going to give me 45 pi here. Now, area of the base. Notice that this base is a square, and we're given the radius, okay? It's a square because it's in a circle, okay? It has to be equally spaced. So for my area of the base, I'm given part of the diagonal. So I'm going to use 1/2 d1 d2. Okay, because I know that if this is 3, then this is also 3, so my whole diagonal is 6. And remember that your diagonals in a square are congruent, so it's going to be 6 times 6. So I'm going to do half of 6 times 6, which is 36 divided by 2, which is going to give me 18 for my area of my base. So this is going to be 18 times the height of the prism is still 5. All right, so I'm going to do 18 times 5, which is 90. Now, to get my total volume, I'm going to take in my calculator, I'm going to do 45 pi minus 90, and I'm going to get 51.4 centimeters cubed. Okay? So go ahead and make sure all that's written down, and then on the next slide here, we're going to start talking about density. Okay, so when we're looking at example 4, we're talking about comparing densities. So what we're looking at here is we have 2 wooden logs that are approximately cylindrical, so that means we're going to be looking at those cylinder formulas. All right, and we want to know which of the 2 types of wood is more dense, the Douglas fir or the American redwood. Well, the first thing that you need to know is that density, if I can spell it, density, is measured by finding the weight of an object, and we divide it by its volume. Okay, so we know the weight of the two wooden logs. So all we have to do is find the volume of each log. So since they're telling us that it's cylindrical, we're going to start with our volume of a cylinder. So volume is pi r squared times height. So we're starting with the Douglas first. So first things first, notice that they give us here that this is diameter. So that means that in this one, if my diameter is 1, my radius is 1/2 or 0.5. It's not going to matter because we're going to end up in decimal anyway. So you can leave it in either format. And our American redwood is, our diameter is 3, so that means our radius is 1.5. Okay, so let's go ahead and plug in what we know. For the Douglas fir, our radius is 0.5, so we're going to square that. We're going to multiply it by the height of the log, which is 6 feet, and then multiply that by pi. I'm going to go ahead right now and leave things in terms of pi because, again, that's more exact and life is easier. So when we do 0.5 squared times 6, we are going to get 1.5 pi feet cubed. Okay, now we're going to turn around and do the same thing for the volume of the American redwood. So it's my same formula because, again, the logs are cylindrical, so it's pi r squared times height. So my volume is, my radius here is 1.5, so I'm going to do 1.5 squared times the height of this log, which is 4 feet, so times 4, and then times my pi. And again, I'm going to go ahead and leave this one in terms of pi. When I do 1.5 squared and I multiply it by 4, I'm going to get 9. So this is going to be 9 pi feet cubed. Now, we want to compare the densities. So remember again that our densities here, because this is in, here, let me slide back up for a second here. Our weight is in pounds in this one. So we're going to be comparing pounds per cubic foot. Okay, so it's going to be weight over volume. So let's start by looking at the Douglas fir. All right, we know that the weight of the Douglas log is 155.5 pounds. We just found the volume was 1.5 pi cubic feet. So I'm going to put that in my calculator. One thing that's important when you're putting this in your calculator is that you put parentheses around this 1.5 pi, because if you don't, you're going to do 155.5 divided by 1.5, then that will be multiplied by pi instead of divided by pi. So make sure you put this whole piece in parentheses in your calculator. And you should get to the nearest tenth, 33.0 pounds per cubic foot. Okay, we're going to do the same thing with the redwood. And our weight for the American redwood is 791.7. And then we found the volume was 9 pi. Again, when you put that in your calculator, put that 9 pi in parentheses. And this is going to give me 28.0 pounds per cubic foot. All right, so now we can see that this is 33 pounds per cubic foot. This is 28 pounds per cubic foot. So the Douglas fir is more dense than the American redwood. Okay, if you guys have questions on that, make sure you write them down, and then I will see you guys in class. Have a great afternoon or evening.